It is moving.
Oh, sorry. One last thing, everyone. The talks are generally recorded, so I hope everyone's comfortable with that. Just in terms of like asking questions, that would be on the recording. We make these recordings available on a YouTube channel. So if anyone wants this recording afterwards, if they want to share it, yes, the recording will be available. And sorry, please continue.
Okay. So hello, everyone. Well, I'm happy to share with you our work at the Data Engineering and Semantics Research Unit at the University of Sfax, Tunisia. Well, I will begin by presenting myself. I am Houcemeddine, Turkey. I am actually a medical student at the Faculty of Medicine of Sfax. I am also a research assistant at the Data Engineering and Semantics Research Unit, working on things like library and information science, biomedical informatics, and information management things. Well, I am actually a member of the Wikindaba Steering Committee, which is an advisory committee for Wikimedia community in Africa. I am also the vice chair of Wikimedia Tunisia user group and a board member of Wikimedia and library user. Okay. So I will begin by giving brief insights about Data Engineering and Semantics Research Unit. Well, the University of Sfax is located in Tunisia, in North Africa. You can see the place of Sfax on the right. It is quite in the south. Well, it is a major university in Tunisia. It is actually among the top 2 in our country. And it is also about the 3 best universities in Africa in computer science research, according to many rankings about research standings. Okay, our team is actually composed of many researchers, but the ones who are working on biomedical informatics are me as a medical student, and Hiba Sbai and Amina Amara as PhD student in computer science, and Muhammad Ali Hashtayeb as an assistant professor, and the lead is Dr. Muhammad bin Awisha, who is an associate professor at the University of Sfax. Well, also, the University of Sfax has teams that are working on various aspects of computer science, particularly all the fields that are represented in the landscape of biomedical informatics here. We are actually working on the representation of medical data and on the knowledge-based reasoning based on medical data and ontologies and something like that. So this is our main fields of interest. Okay. Well, concerning our work, we have actually succeeded to publish many papers. Actually, we have published more than 6 papers in major research journals. Okay, we have 1 letter in Prefix in Bioinformatics published this year. We have a letter and a paper published in Journal of Biomedical Informatics. We have a letter published in Journal of Clinical Epidemiology. We have a paper published in Applied Intelligence. We have a letter published in Journal of the American Medical Informatics Association. We have a paper published in Journal of Information Science. And we have our recent paper that has been published in Semantic Web Journal. Well, so after this brief introduction, let's move to the main topic of this talk. Okay, so I will begin by an introduction. So, as you already know, machine learning applications should follow several series of steps to ensure that the application that will be developed is accurate and working. Well, it all starts with the collection of data, pre-processing it, constructing the model, for the machine learning, training the data, represent the results, and evaluate the results and adjust the results accordingly. And the model as well, you can adjust the model. So these are the steps. Well, when doing these steps, you should ensure that your your machine learning application is trustworthy. What does it mean to be trustworthy? In fact, it should be fair. It should be fair and unbiased. It should be explainable. It should be robust to adversarial attack. It should be secure. It should be appropriate for the application, and it should attribute the model to its sources, etc. So these kinds of criteria should be respected across the 6 steps of machine learning application development that were explained earlier. Okay, well, the common techniques that are used in machine learning do not ensure such things. In fact, the major biomedical ML applications are based on topic modeling, on word network and graph embeddings, or on deep and machine learning. Well, these kind of techniques are purely statistical, are not very valuable. Well, they can have an interesting accuracy, but we cannot explain why they are accurate. They are the so-called black boxes. As well, these techniques require lots of money, lots of energy consumption, and a robust infrastructure, which is not available in Africa. I would just give a brief insight of explainability here. Well, as I said, these models, these 3 methods that I have shown here are black boxes, and this means that their results are not explainable. So what is explainability? Well, the explainability should involve 3 steps: the pre-modeling explainability, the explainable modeling, and the post-modeling explainability. In brief, the pre-modeling explainability should be a kind of a way of understanding the data that you have between your hands. For example, if you have a set of processed images, for example, an X-ray images, you have to understand how they have been processed to achieve the input that you will use in your training process. For example, if it's submitted max pooling, if it has been cropped, it has been like processed, or it has been color changed, etc., etc. The explainable modeling is that you need to know why you are using such a model, not just because it ensures a good precision rate. You have to know why why you had to choose this model, for example, the SVM, and not another model, for example, the neural networks, deep learning, or graph embedding, etc., etc. The post-modeling explainability, you should know when you have the results, you should know why the results that were wrong, for example, the false positives, why they were false positives. So if you don't have this, you cannot proceed with a trustworthy AI or ML application. Okay, so let's move to the situation of Africa now. Well, as you see here, this is the Human Development Index as shown by the 2020 report of the UNDP. Well, as you see here, the countries that were colored in green are the countries with high development. This means they are quite wealthy, but not too much. They have quite good life standards, but this is questionable. Okay, well, they are in stable situation overall, but the ones in red or in orange are the countries who are suffering from lack of resources, financial mainly. They are suffering from problems, maybe health problems, maybe social problems, etc., etc. And as you see here, most of the continent is colored in red. So no one can afford in the continent, in sub-Saharan Africa, to purchase a GPU for applying GPT-3, for example, to a set of data. Well, this is quite often translated by the standings of African country in computer science research. As you see here, the best countries in the world are the United States, China, Germany, India, and the United Kingdom have more than 300,000 publications between 1996 and 2019. Whereas the best country in Africa, which is Egypt, has 26,000 papers in the same period. Quite a huge difference. And as you see here, the imitating what the trends that are quite available or followed by Western university cannot be applied in Africa in a consistent way. And this will make the gap between the countries in Europe, in the United States, and even in the growing world, like the BRICS countries, and huge and the difference between them and the developing countries, particularly the African countries, very significant. Okay, so as you see here, we need to think about simple way to develop cheaper and more effective computer research in Africa, particularly in the context of biomedical ML. Well, to do that, we will explain how how we can achieve the 6 steps that we have discussed earlier for developing machine learning applications in a cheaper way. Okay, we will start by the data collection here. Okay, we have too many options to get free data online. Okay, the first option is to use the social media. Well, the social media have many interesting features. It has an ever-growing volume. It is ever-growing. It has a variety of information, social information, maybe information about trends, about dislikes, likes, etc., etc. The values, and they are real because they are inputted by real people. Okay. Well, in the context of biomedical informatics, social media analysis can reflect the general thought of the assessed population about the crisis. For example, COVID-19. Well, it can assess the interest of users to a given topic in the context of public health. You can apply NLP techniques on posts, analyze shares, like and dislikes, and create networks of information diffusion. It can allow as well the monitoring of general audience, evaluating user sentiments, predicting future behavior, identifying the spread of the crisis through epidemiology study, recommended actions and resources. to tackle, for example, rumors. Okay. The second thing that social media analysis can be used for is to assess the information diffusion about the crisis, about the health crisis. Okay, it can evaluate the spread of institution and specialized information across social media by analyzing sharing a network of institution and specialized posts, for example, the ones of the Ministry of Health, and it identifies the reactions to official posts. It can identify the misinformation and the rumor across social media by detecting inconsistent posts by comparing them to ontologies and scholarly publications. I will go to that later. And finding accurate posts and knowledge to fight crisis misinformation. Okay, the second option, well, there are many HTML pages across the internet that can involve plenty of good information. So you can use web scraping tool. There are many web scraping tools across the web. So you can use them. You can use these libraries. You can get them, and you can program them so that they extract information from a particular website. And this can generate dynamic output that can be updated as soon as their source page are adjusted. Because if they are scraping data from, for example, a series of web pages, when the web pages will be updated, they will be updated as well. Because web scraping tool do not miss the link between the source file and the data resource that is created. Okay. The third option that is very important, at least for me, is the Wikimedia projects that are freely available online. Well, as you see here, there are many types of wikis. Okay, there is Wikipedia, which is the free encyclopedia that you know all. There is Wiktionary, which is a dictionary that is available for free, etc., etc. There is Wikinews, which is a site for citizen journalism. Wikivoyage, well, this is not important for us, but what is important is Wikiversity, for example, which provide free learning resources. Wikisource, which provide some public domain content, and Wikibook that affords textbook content, etc., etc. Okay. There is also Wikimedia Commons, that is a free media repository involving thousands of medical images. There is many immunohistology images. There are pathology images. There are images of organs, etc., etc. So it is a good resource, and the images there are free also. There is Wikidata, which is a knowledge graph. It is a fully structured knowledge base involving, among the other types of information, medical information, etc. And there are many other resources. So we will not be going into details. But okay, what you need to know is that Wikimedia projects include various types of information in multiple natural languages, including African ones. Is that Wikimedia projects are available for free with APIs and programming tools, and they are findable, accessible, interoperable, and reusable, because they are using the CC licenses, the Creative Commons licenses that allow the attribution and while sharing and distributing the data. Okay. Okay. What are the types of useful resources that can be found in the Wikimedia projects? There are two types. Okay, there are the biomedical data itself. Well, as I said, there are many biomedical images in Wikimedia Commons. There are biomedical information available in Wikipedia articles. There are many biomedical categories in Wikipedia and other projects. that can be useful for constructing semantic resources and driving supervised classification algorithms. There is the fully structured biomedical knowledge graph available in Wikidata, and there are statistical data about editing and readership of pages, mainly in Wikipedia. Okay, as for the free software here, there are many scripts and programs and codes that are created by a community of developers to manage Wikimedia projects. Well, these codes are freely available and can be reused in other, for example, applications in a biomedical information system. For example, you can get them, fork it, and adjust it and adapt it to your context. Okay, there is the MediaWiki, which is the software driving Wikipedia and other wikis, and can be used to host electronic health records and biomedical database, particularly the semantic web edition, which is called Semantic MediaWiki. Okay, there is also Wikibase, which is the software behind Wikidata that can be effective to host biomedical information, and it can apply reasoning rules on clinical information using Sparkle query service for clinical decision support, as well as for data validation and augmentation. Okay, let's move to the option 4, where we have, as far as we begin, we have identified 3 options to have free data. Okay, there is a 4th option, which is the use of biomedical knowledge graph, where knowledge graphs are fully structured resources where statements are represented in the form of triples, as you see on the left. It is subject, predicate, object, where the statements are only is relations between entities, instance of, subclass of, part of. It is called the whole knowledge graph is called the taxonomy. When the statements are only relations between entities, it is called ontology. Where the object is a string or something like that, it is called knowledge graph. It is neither taxonomy, neither an ontology. Okay. So as you see here, knowledge graph can be easily constructed, enriched, and validated from raw data, as well as from semi-structured or structured data, and can be easily found. You can use Google and write biomedical ontology, for example, and you get thousands of results. You can search that on GitHub, on many websites, and you will find it. So this is not difficult to find. Okay. Well, there are currently plenty of freely available biomedical and biological knowledge resources in the linked open data cloud, which is a cloud of biomedical ontologies. Well, it is not biomedical ontologies, it is multidisciplinary ontologies. It is ontologies about health, about linguistics, about geography, about social sciences. It is all kinds of semantic stuff, semantic resources that are available there. They are free, they are usable. So you can get to the website of the linked open data cloud and search it, and you will get thousands, hundreds of life science and medical ontologies, taxonomies, and knowledge graphs, as you see here in yellow. Well, the ones that are practically near the linguistic one is about psychology, sociology, about speech, etc., etc. The ones here is about mainly about genetic information, about clinical information, etc., etc. The ones here near the government ontologies and knowledge resources are mainly the public health ones. So you will have many clusters of biomedical knowledge resources that is available. So please feel free to access this this resource. Okay, the second option is to use the NCBI resource. These resources are made available by the National Institutes of Health in the United States of America, provides various types of biomedical informations for free, including bibliographical, clinical, and genomic data. They are accessible at this website, the ncbi.lmn.nih.gov. And you will find plenty of stuff. For example, PubMed, which is a citation index, providing the metadata of millions of biomedical papers. MESH, which is a taxonomy about the biomedical terms. Biosamples, for example, that contains description of biological source materials used in experimental assays. The PubMed Central, which is a database of full text of biomedical and life science journals, etc., etc. So reuse is possible thanks to the free APIs, particularly the Entree APIs. However, certain conditions have to be fulfilled, such as, for example, the time limit for a query. You have to sign an agreement to use some resources, etc., etc. But it is free, so you can make an application and you can reuse the data without any problem. Okay. Well, it is up to the user to choose which NCBI resources are useful for his application to make his own source and to drive his applications. For example, the mesh keywords of PubMed scholarly publications can be used to automatically generate the skeleton of a biomedical ontology. So, but it is up to you. Well, everyone can work on different type of biomedical application and like this. So but there is plenty of associations that can be used to generate biomedical information. Okay. The second option is to use the open data platforms. Well, there are the African open data platforms. There are many ones. There is the one of South Africa, Kenya, in Ghana. There is Open Africa. There is the Africa Information Highway, etc., etc. Well, this kind of platforms in Africa can be useful to retrieve social, economic information about African country, but it does not provide sufficient data about the biomedical field. Datasets are static file and statistical file actually, and are not linked to each other. So they are not dynamic. They are just Excel files, CSV files, etc., etc. So it is an option to follow. For example, if you are working in the public health sector, you can have usefulness in using that. Okay, and the second option is to use the data repositories. There are many data repositories, for example, Zenodo, Figshare, and they provide datasets that were already used in research projects. This data can be described in data articles available in journals like Data and Brief, and that's why I invite you to read the journals that are publishing data publications, because they can bring you some datasets that can be useful for your applications. And there are variety of data types and topics for these datasets that are available in data repository. So you can have a choice to find what you need for your work. Okay, well, this is actually the option 7. The option 7 is to use public IoT API. Well, limited people in Africa can purchase or buy IoT devices, Internet of Things devices. For example, items for measuring temperature or for using CO2 emission, etc., etc. But some people who are acquiring these devices make the output of their devices free for users. In fact, there are many IoT devices that can be explored using APIs online. You don't have the device, but you can access its output easily and freely. Well, these IoT devices that are having a freely available output can return various interesting types of data, including weather and gas emission. Okay, as I said, the data is extracted from the API of IoT devices, and these public IoT APIs can be easily found using specific search engine such as Shodan. So as you see, you can write here, this is shodan.io. You can write the kind of information that you need to know. For example, I need an API for an IoT device that gives a CO2 emission in particular countries. And you write here and you click on search and you get the IoT devices and their APIs, and you access the API and you programmatically can get all its output in real time, even for today, for yesterday, for the previous month, etc., etc. Okay, so this is all for data collection. So people that are saying that data collection is limited in Africa, there is plenty of solutions for that. So let's move to the pre-processing thing. Okay, the first option you have for pre-processing, because many people do not have servers to process data, etc., and manual processing can be, pre-processing of data can be a bit difficult for one individual or two, etc. There are some options for that purpose. Okay, the first option is to use Excel. Well, Excel has many hidden features where they are taught in primary schools, well, 10 years ago, etc., but now they are not taught to the public, unfortunately. But you can learn about them. Okay, for example, you can automate data cleansing, for example, using the VPA services of Excel. There is a full guide about how to use Excel as well as other software, which is written on the right here, the tutorial. It is AI research without coding, the art of fighting without fighting. And you will find plenty of tricks like this about using Excel, using other software, and this is very useful. Okay, I highly invite you to read this paper. Okay, the second option is to filter your data. Use the criterion to filter your initial data and eliminate odd information. The criterion can be a particular value of a given metadata. I had given two examples here on the right. Right. The first, let us suppose something. Let us suppose that we are getting, for example, we need to retrieve the metadata about the drug therapy of hepatitis C, for example. And you have made your query and you extracted the fields and the metadata from PubMed, for example. There is first option, you can use the mesh term to filter the data. So for example, the articles that do not have hepatitis C with drug therapy as a qualifier, they will not be considered and they will be eliminated. For example, you can draw the citation network of the paper, and you will find the papers that do not cite any paper from the search results. So they are certainly they are outliers because they do not cite any paper that deal with the drug therapy of hepatitis C. How can this paper be a paper about drug therapy of hepatitis C? The third option that we have here is to use the knowledge graph. Okay, when in line to your initial dataset, knowledge graph can provide additional information about your records. These additional records can be classes or relations of named entities. Additional information can help filtering the initial data according to semantic features. Okay. So now we have discussed all the tricks about simplifying pre-processing. So let's move to the tricks that can make your model construction more effective at a limited cost. Okay, the first option, I think it is quite of trivial and even ridiculous for some people. It is to look at the previous research paper. You can search for ML applications for the purpose of your project and read the methods part as well as the result and discussion part. For example, here in the example, I have searched the machine learning techniques for the classification of heart disease. I have get these results. I clicked in one of them and I went forward to the methods part, and I have seen here many details about the model they have used, with the details with the parameters they have selected, etc., etc. The architecture that have been developed for hosting the model, etc., etc. So this can be a good choice at the first sight. The second option, which can be ridiculous as well for some people, is to know the K-12 STEM knowledge. STEM stands for Science, Technology, Engineering, and Mathematics. While principles of the science, technology, and engineering and mathematics can particularly prevent precision loss from the computations in a machine learning algorithm. For example, as I am a lazy medical student, I have done a game with Python. I have done some tests one day, and I decided to calculate for a trivial reason to calculate 0.3 plus 0.6. And the result should be 0.9. But what I found out is that it is 0.899999999. And when I compared 0.9 with 0.3 plus 0.6, I found that the difference is 10 to the power of minus 16. So it is too limited. But let's consider that the machine learning algorithm should work on an infinitely small variation of a metric, for example. And if this metric slightly differs, this can falsify all the computation. And this is common in the bioinformatics field. Well, this can harm the whole process of ML algorithm, and you will get false values of inefficiencies while your model is good and is working, etc., etc. Well, just to note, there are many papers in a bioinformatics journal that are pointing to the floating points numbers problem here, but they do not give answers. They just say that we have some turbulence of the results because of the floating point thing, and that's all, and this is a limitation, and we will look forward to solving it. Points. Well, here if they knew why this result of the computation of floating points returns such errors, they can solve the problem easily without having to state limitations and without having to suffer. Well, let us give the solution to this problem. For example, the problem is that the representation of floating point number is made according to the I.3754 recommendation. And this kind of recommendation requires that the representation of a floating point is represented across 32 bits only. And as you might think, this 32 bits will not be able to address every single digits of a computation. It will just be sufficient to represent the results of a computation at a very small scale. For example, the result will be precise to the 10 power minus 16 only. So this is the problem. Well, the solution is that if one person has done 3 out of 10 plus 6 out of 10 instead of 0.3 plus 6 0.6, he will get 0.9. And the solution is not to use this floating point too much. This floating point representation too much. It is the computer developer should use as much as fractions and as integers as possible, and by that he will get the precise result that he needs for his computation. Okay, just a side note here that floating point arithmetic is not only useful for this kind of problems related to computations, but also it can be useful for ensuring blockchain security thanks to the modulo operator. Okay, the option 3 we have here is to use the open source libraries, software, and codes. There are plenty of freely shared codes and architecture online, and you have just to search for them in repositories, for example, GitHub, or packages indexes like PY, for example, to find them. For example, the BioPython, which is a set of freely available tools for biological computations written in Python. Okay. So this is about the model construction. Now let's move to the training. Okay. If you are dealing with big data and you don't have the means to purchase, for example, cloud storage, etc., there are many free services that provide big data infrastructure. For example, there is for example, there is the infrastructure as a service, the platform as a service, and software as a service applications that are available online. Well, a user-friendly list of resources is available at free4.dev. This website is quite excellent. I recommend it for such a purpose. Okay. Let's move to the output representation. How you can represent your data in an effective way so that you can benefit from it as much as possible. Well, there are two options. Since the beginning, I have said it. There are two options for represented data. Either you represent it as a table or you represent it as a knowledge graph. Okay, the tables use common formats like Excel spreadsheet, CSV, TSV. Records are rows, columns are variables. Basic relations using human efforts and programming. Static, but cannot be integrated unless it is related together in a relational database and processed using SQL queries. And they are mostly monolingual. But if you use the knowledge graph, well, the common formats are XML, RDF, and OWL. Entities are assigned to items described using statements in the form of triples. Well, it is true that it requires extensive data modeling before creation, but can be aligned to other databases and queried using Sparkle to extract feature or generate new knowledge. And please uh, remind yourself of the LOD cloud, the linked open data cloud that I described earlier in a previous slide. And you will know the context that of what I'm talking about. Okay, so knowledge graph can be enriched with logical constraints, description logic for knowledge-based validation, by contrast to the tables that cannot provide such a feature, and can be multilingual because you are representing entities as items, and items can be assigned many labels as possible. Okay, so let's focus on an example of knowledge graph. Well, here Wikidata. Wikidata is a multilingual knowledge graph, as I said earlier, and we have developed it into large-scale database of COVID-19 information. As you see here, thanks to data federation and integration, we have made a multidisciplinary representation of COVID-19 information in a small amount of time, as you see here. And this data can be federated and integrated together to generate, for example, a sophisticated output. For example, here, the famous dead people by type of occupation. For example, the politicians have died the most, with physicians and nurses and university teachers, etc., etc. Okay. I will move now to the evaluation and advancements. Okay. Well, as you already know, the common metrics that are used in evaluation of adjustment are precision, recall, accuracy, and metrics, Hamming loss for multi-label classification, and confusion matrices, ROGs, and ROG Gini. So as you see here, they are fully statistical way. They are just dependent on probabilities, etc., etc. So I will quote here something I have heard from the keynote of Rada Mihailska from the ACA conference in 2021, just a few days ago. She said that machine learning algorithm evaluation should be expanded to cover interpretability, generalizability, ethics, social good impact, reduced environmental and financial costs, and diversity and equal opportunity. ML output can bring a solution to that. While classes in supervised classification, as well as entities and statements in knowledge graph, are generally labeled in natural language and have consequently semantic values. And considering this semantic data of the output, well, it will be useful to improve the assessment of ML applications in several ways. I will go through some examples here to be clear. Okay, the example one here. The constraint is evaluation of semantic relations. Well, it evaluates if a learned semantic relation is conflicting with the constraints defined for the considered relation type in a reference knowledge graph. For example, learned relation here. So hepatitis C is the drug used for treatment of Sabosvir, for example. The constraint says that the subject should be an instance of drug and the object should be an instance of disease. When applying these constraints to the learned relation, we can see that the evaluation bring that the relation is false because there is a subject-object inversion. Where there is a paper of Al-Shahrani et al. About this, and I recommend reading it. Okay, the second option, the second example I am sharing here is the hierarchical multi-label classification. In fact, it splits the multi-label classification into a series of mono-label classifications using Bayesian reasoning. For example, the outcome here will be the division of the original classification into a series of mono-label classifications where the classes are direct subclasses of the same parent class. For example, let me consider that there is an ML algorithm, multi-label classification algorithm that considers the following classes: yellow, white, black, gray, Persian cat, pink cat, Munchkin cat, Scottish fold. Well, this classification will be split into two. The first one is yellow, white, black, gray, because these are all colors. And the second one will generate Persian cat, Bengal cat, Munchkin cat, and Scottish fold, because these are all cat breeds. So there is a paper about that in the International Conference on Machine Learning, published in 2018, about Verman and all, and it is a paper worth reading. Okay, the third option, the third example that I will explain here is the inductive multi-label classification. In fact, it adds a class to the multi-label classification output for an item when its components are recognized. Example here, eye, nose, and mouth are recognized in a given image. Eyes, nose, and mouth are all parts of a face. Face should be recognized in the assessed images. So it is a paper of Sarkar et al. In 2020. So it is quite a recent paper. A third example that I will share with you also, it is the propensity scored loss. Well, it is an adjusted Hamming loss that do not consider the non-consideration of a class by an assessed multi-label classification algorithm when one of its subclasses is recognized. For example, let me see that. Let me suppose that there is an image that should have as labels cat and Persian cat, and the predicted labels by the algorithm did predict only Persian cat. Well, Persian cat is also a subclass of cat. Therefore, cat should be considered as it was predicted by the algorithm, because the algorithm predicted the Persian cat, which is a subclass of cat. So this is this has been proposed by Jane et al. In 2016 in CKDD conference. This is also a good example. Well, I'm working on two other examples of such a way of knowledge-based evaluation of ML algorithms, but they were not published yet. So unfortunately, well, this is with this I wrap up all the tricks that I have in mind and that had been working on by our team. I just will give you some practical examples and wrap up the whole presentation. Okay. Well, the example I am sharing here is a system which is called Spittoon. It is available in this website. Spittoon is a system that generates the trends of Tunisian people in social networks about COVID-19 and proposes scholarly articles to tackle these types of fears and concerns of the Tunisian people based on what they have discussed in social networks. So it is quite simple. Well, we are taking we are extracting all the posts in Facebook about COVID-19 posted by Tunisian people using web scraping tools, and we are organizing them in a knowledge graph, as you see here. And then we are doing topic modeling using a freely available library to generate the topics that were dealt by the Tunisians. And we are making use of knowledge resources like Wikidata and Mesh when generated topics, because the topics should be related to the medical problem and not to other problems. And then we use the Entree API to find the papers in PubMed Central that deal with the problems that and the concerns that were shown by the LDA. The topic, I mean the topic modeling. Okay, as you see here, the tricks that I have explained here have been useful to generate the tendencies and the trends of Tunisians in social networks related to COVID-19 with a high precision. So you have here coronavirus, we have lockdown, we have Tunis, we have pandemic, we have God. So we have plenty of things. Okay. So, and then we have generated the articles related to concerns. And as you see here, we have extracted, for example, a paper that that deals with the religious expression related to COVID-19. This can be sent to the Ministry of Health and can be studied to identify how the Ministry of of Health can deal with the holy concerns and the holy expressions of the people related to COVID-19. Okay, so another thing we have generated here is a questionnaire that is used to predict if a person has been affected by COVID-19 or not. In fact, you fill plenty of information that are, for example, the age, your medical history, your symptoms, etc., etc., and it gives you a rate. So for that, we have used the data sets that are available on GitHub to generate this system. So all is free. We have found plenty of clinical data related to COVID-19. We have just reused them. We have pre-processed them to align the fields across the different databases, and we have reused them, and we got good results. Okay, as you see here, all this has been done using several servers. This costs around $30,000 only. And if we do not use our tricks, it can cost around $90,000. So we have saved around $60,000 just by using simple things that can be used by everyone to generate free and low-code solutions. Okay. Well, we are not the only people that are going through these tricks. Well, Google as well has used these tricks. Okay, in the Olympics, you have probably seen this kind of features. Well, this is a knowledge graph that is linked to IoT devices in Tokyo, and where they are updated, the results are used automatically to feed the knowledge graph, and the information is updated and vice versa in real time. The second thing that Google has done is this Google Doodle game, which is called Champion Island, which used a low resource. It is 16-bit game, so they used a simple solution that was used in the 90s to generate a game that can be generated and loaded even in a computer with low capacities, for example, in Africa. The game had actually successful have achieved successful results and a rate of participation and usage from all over the world, because it is simple to load, etc., etc. Okay, so last but not least, so I have finished all what I have to share. Okay, last but not least, I would have to thank the Ministry of Higher Education and Scientific Research in Tunisia for supporting this research in the framework of the Federated Research Project PRF Gov19 D1P1. And I will have to share the series of our publications that were published in this context. You see here we have a recent machine learning survey here about network representation that will appear soon in machine learning applications. We have numerous papers about semantic technologies, about social media analysis, about semantic resources, particularly Wikidata, and its use in biomedical informatics, trustworthy AI and elementary STEM in bioinformatics, and bibliometric enhanced information retrieval. This means the use of metadata for the pre-processing of scholarly publications in the context of the automation of systematic reviews, etc. Finally, I would have to share with you our initiative, the X-Roads Research Hub, which is a joint initiative of Data Engineering and Semantics Research Unit at the University of Pretoria, particularly the Institute for Technological Innovation, and the School of Data Science of the University of Virginia. X-Roads is an initiative that looks forward to create a consortium to spread low-cost and low-code development across Africa, particularly in the context of health. And I will be happy if Sisonke Biotech can join this effort. Thank you very much. This is my contact. If you have any question or you need any data or any overview of a few things, you can contact me and I will be happy to respond to you. Thank you.
Thank you so much for that talk. There's so much about that talk that I really enjoyed. I mean, I personally am just such a big fan of graph representations, just because they're super powerful. And I mean, knowledge graphs in particular, but more, you know, I'm also a big interest in like graph representations for other parts of biology. Yeah, thank you. That was a fantastic talk. I think that the topics that you covered were particularly pertinent to the Sisonke Biotech community. I mean, I think you guys you know, have just really hit the nail on the head when it comes to your approach at trying to, first of all, bridge the gap between like really deep machine learning concepts and healthcare. And what I really like as well is that very often you'll go to a conference and you'll hear people speak about some sort of performance gain or some result that they got in their machine learning work. And then you ask them, well, how do you plan to implement this? How is this going to benefit the patients? And very often the response to that is, no, that's someone else's job. We're just doing the fundamental research. Someone else can do the application. Not only have you and your group put together the research, you've also put together a functioning system, and you have the proof of concept, and it's working, and it's up. And I'd be really interested to know. So we can open for questions now. I'm going to start with a question on my own, just around. Because we are a community here of machine learning individuals and healthcare. So let me just also point out that I know that some of the jargon might be a little bit inaccessible to people from a healthcare background. So in the chat, if you guys would like to just put up any words that might have been a little bit vague or inaccessible, and we'll try unpack that for you. I think in future, we'll try to keep track of those during the talk. But yeah, don't feel bad if some of that went over your head. So my first question here is, if there were a doctor or a nurse or a healthcare practitioner, how would they go about interacting and using this resource that you guys have put together? Could you maybe give an example of a situation where you could see them using this? And I know you've given some practical examples.
There are many situations actually. I can talk about something that is actually in use, which is the Wiki Gene project, where they are representing genomic information in the form of triples in Wikidata. And many institutions across the Netherlands, Belgium, and many other countries are using this data for analyzing and for interpreting the genomic analysis, for example, for recognizing a disease, for example, etc., etc. So this is an application, but this is way too advanced. So what we can do in Tunisia and in Africa in general is that, for example, we can, for example, represent, for example, words, for example, in dialects, in dialectal Arabic, for example. And the concepts we have the concept in French, in English, in Arabic, etc., etc. And then you can use this data to find the data, its equivalent in, for example, in Arabic dialect, or for example, in South Africa, where there are 13 languages that are operated together. You can find, for example, the word in Zulu. And as it is a knowledge graph, you will have all the related concepts written in Zulu as well. For example, the symptoms. For example, if you are thinking about, for example, hepatitis, you will find all the symptoms written in Zulu with all the drugs written in Zulu with all the types of relations that are written all in Zulu, and this will ameliorate the communications between physicians and patients, particularly as the medical education in Africa is mainly given in English and French, and this is a huge problem. So this is a first application at first sight. We have been working on that for a while, but we did not have, let's see, the courage to make this into practice, because this is way political. Because you see that they are considering English and French and Arabic as the standard for speaking, and the other languages and dialects as minority things. And this should have political, let's say, will to make this into practice in order to let this operate. Well, we don't have this kind of will, unfortunately. The same for example, we have thought of creating a fully structured electronic health record, which is simple to operate. For example, you can translate it in plenty of languages because it is fully structured. And for example, you can send a folder, for example, of patient to a doctor in Japan who is specialized, for example, in gastroenterology, because gastroenterology in Japan is advanced. And so you can have data of your patient in Japanese, and you will get the answer with details from Japanese colleague, etc. But this is also this has been rejected as well, unfortunately. But if Sisonke Beauty can manage this to happen, I will be happy.
Thanks. I appreciate the examples you gave there. I'm not sure how much political will we can muster, but I must say we really appreciate the invitation to collaborate. And at least from my side, I can say that we are very interested, and I'd like to definitely chat to you about this offline. And I mean, I think from our side, what we can do is try to help provide you an audience, as we have this evening, as well as you know, a group of individuals who are interested in, you know, both the fundamental you know, academic aspects of this when it comes to you know, the workings of knowledge graphs, and you know, topics around machine learning in terms of like natural language processing and healthcare, as well as potential places to, or individuals to connect with, to you know, talk about application, right? So that's what I hope our community would be able to provide. But yeah, let's chat about it. I'll say come join us at a weekly meet, and we can take it from there. Are there any other questions going forward? I do realize that we're a bit over time, so I'm, you know, also because we're a bit of a smaller group this evening, I think we will forego the breakout rooms if there's no protest to that, and maybe just have some conversations around now, like a little bit more free form. So yeah, any other questions?
Yeah, I have some questions in the chat. I have seen them. Okay, so what is the source of that citation count? It is a question by Jade, I think. Well, if you are talking about the citation network that I have generated to select the research article for a survey and eliminate outliers, it is generated using VozViewer and based off the data of Web of Science, which is a database that is curated by Clarivat Analytics. It is freely available in Tunisia, but I don't know if it is freely available in other countries of Africa. Well, if you are talking about our citation count, please feel free to see our Google Scholar profiles. Probably I will make them in the chat. Okay, I will make 2 of our team in the chat. Okay. Okay. These are the citation count of our projects based on Google Scholar. Okay, Daria said I would like to join this research. Where do I start? Okay. I don't know if this is about our research. If you would like to join, please feel free to contact me in my email address. I will share it with you. Okay. Okay.
Would you perhaps like to have a channel in the community Discord to chat around this project? You can use that if you like as an entry point to your project.
Okay, but I don't mind. Okay, I have shared already my email as well as the email of the head of our research unit. So if she would like, or everyone would like to collaborate with us in any project, not just this one, we are interested and feel free to contact us. Okay. Okay, I think these are all the questions I have here. There is Ismail. There's Ismail that who says, can you share the github.com repository you mentioned? Well, I just gave an example, but you can search and find one for your convenience. Well, I did not talk about specific ones. I just shared one as an example. So if you have an application, feel free to search GitHub and you will find one. This is for sure. Okay, these are all the questions I have here. I think we are finished with that, I think.
Sure, thanks. I see Brad had a comment there. He's not here anymore, but he said he's keen to chat about knowledge graphs and multi-label hierarchy learning. He's got a project in the works on extract classification. I'm sure you'll be able to contact him through the community Discord. I know he's doing some work on synthetic data using GANs. He is also our speaker for next month. Well, the end of this month, the last Thursday of this month, we'll be having another talk from Brad on synthetic data for healthcare. Cool. It is 7:30, so I think we'll try bring this to close fairly soon. I know it's been sort of an hour and a half. However, if anyone wants to hang around and chat, I am here as long as anyone wants to chat. Because what we want to do, Sasonke, is try and build, like many to many relationships between, all the different community members. So if we can get individuals interacting with one another, that is our goal. However, I'd just like to thank you again for your talk, because I did really think it was superb. I know it's quite hard in these formats where you're just talking, at a screen for some time. We're going to try and work on formats that are a little bit more interactive. I know Crowdcast is an option. I think that makes answering questions a little bit better. We've also seen that Discord has their own speaker platform. So yeah, we want to try and get it a little bit more interactive next time. But yeah, superb talk. Before we bring it to a close for this evening, is there anything that anyone wants to chat about? Or if anyone has any more questions about the community in general? Cool. Well, yeah, if there's nothing else, I'd encourage anyone who wants to get more involved to join us at our weekly meets, or to reach out on the Discord. But yeah, this has been a really interesting talk. I'm actually quite keen to chat to you a little bit more just around these topics. I also think there are some community members from the Masekane group who also have a interest in natural language processing and healthcare and making data accessible, in multiple African languages, who would be keen to chat to you around this. So I may just try set up a meet amongst that subgroup of the two communities as well, if you're interested. But yeah, thanks everyone. I look forward to getting to know you all in further meetings where we have a little bit more time to chat one-on-one. Okay, yeah, so otherwise, I'll say, yeah, thanks for the evening, and yeah, until next time. If no one wants to chat about anything, we can call it a night. Yeah, I'm just gonna hang around in case anyone does want to chat. But otherwise, yeah, that's us for this evening. Thanks, everyone.
Chris, hey.
Hey, Archie. Hey.
Hello. I came towards the end, but what I caught in the last bits is extremely interesting. I think there's definitely some collaboration opportunities here. Quite keen.